Water pollution. Water in abundant amount is required for use in agriculture, industry and household. After use, however, it gets highly polluted. The various water pollutants can be classified into as many as 10 categories. These are discussed below in some details. Various water pollutants. First, sewage and other oxygen demanding waste. Sewage from municipalities and other oxygen demanding waste from industry and agriculture comprise of organic matter which undergoes oxidation readily under the action of the microorganisms. These wastes are generally disposed of by dumping them into nearby rivers. If the amount of sewage or other waste discharged is relatively small, the dissolved oxygen is sufficient to convert carbon into carbon dioxide, sulfur into sulfates, phosphorus into phosphates, and nitrogen into ammonia and nitrates, and the river water is not so badly polluted. If, however, the amount of discharge is heavy and the dissolved oxygen becomes insufficient, carbon is converted to methane and nitrogen compounds are converted to amines which give offensive odor of rotten fish decaying in a cesspool. The sulfur compounds change into hydrogen sulfide which gives smell like that of rotten eggs, and phosphorus compound produce give a wormy odor. Thus sewage and other oxygen demanding waste become water pollutants on two accounts. First, they give rise to compounds which have an extremely annoying odor. Second, they deplete the dissolved oxygen from the water which is rendered harmful because water devoid of dissolved oxygen can't sustain aquatic life. It affects or even kill fish or other aquatic living beings. Second one, infectious agent. Sewage from the municipalities is almost invariably associated with disease microorganisms. This is due to the fact that in fair-sized community, a few inhabitants at any given time must be suffering from disease such as dysentery, typhoid, cholera, etc. The feces and the urine of such patient would contain disease microorganisms which are transmitted through water supplies. Thus, wastewater from the municipalities would almost invariably carry agents which produce disease in other living beings, man and animals, including livestock. Third one, plant nutrients. The presence of the plant nutrients in lake and slow moving waters supports high population of aquatic plants which on decay produce disagreeable odor. Not only this, these plants also deplete dissolved oxygen, making the survival of the aquatic fish problematic. The enrichment of the water by nutrients is known as eutrophication. Lakes and slow moving waters age through the eutrophication, and over periods of several millennia they get converted into swamps and the marshes. Eutrophication has an adverse effect on fish as well. The aquatic plants which bloom in lakes sink in autumn and winter and decay the next summer, depleting oxygen from the lower, colder parts of the lake. The cold water fish, which according to Darwin's theory get habituated to require more oxygen for their growth, have to face shortage of dissolved oxygen. As a result, the cold water fish lose out to warm water fish which need less oxygen. Humans who prefer cold water fish are thus deprived of getting their choice fish. Fourth one, exotic organic chemicals. The exotic organic chemicals include pesticides, surfactants, among us detergents, many industrial products, and several decomposition products of other organic compounds. Analysis of polluted water reveal the presence of a wide cross section of these compounds as also many others. These organic chemicals are generally toxic to fish. Some of these are toxic even at extremely low concentration around 1 ppm. With the fast development of the chemical industry, several new organic chemical compounds are introduced every year, which may find their way into rivers and the lakes. Since the effect of these new compounds on natural ecosystem may not be known, there is every possibility that an irreparable damage is done before scientists realize it. Fifth one, inorganic minerals and chemical compounds. A large variety of inorganic chemicals find their way into normal water from the municipal and the industrial wastewater and urban runoffs. These pollutants, comprising of compounds of lead, arsenic, cadmium, sodium, calcium, fluorine, etc., injure or kill fish and other aquatic life and also render the water unfit for drinking or for industrial use. A prominent example is the presence of mercury in water. At one time, it was believed that metallic mercury sinks into the sediments and remains there in chemically inert metallic form. But now it is known that anaerobic bacteria in bottom muds convert inorganic mercury into methyl mercury, that is CH3Hg positive, which can lead to mercury poisoning in living beings. In petroleum drilling, brine is discharged along with the crude oil when the latter is pumped to the surface. Sometimes the volume of brine may be more than the 3 times the volume of the crude oil recovered. This brine is a potential pollutant for water. Minerals containing sulfur, example iron pyrites, copper pyrites, on coming in contact with air and the water yield sulfuric acid, which is carried into lakes and the rivers by water draining from the mines. The presence of the acid affects aquatic life. In cold countries, NaCl and calcium chloride are added in large amount to melt the snow from the roads in winter. These salts eventually run off the roads and contaminate well water and also find their way into lakes and the river, seriously affect the aquatic life. Some other metals whose compounds frequently act as water pollutants are lead, arsenic and the cadmium. Lead. Compounds of the lead which enter into water are PbCl2, PbBr2, PbBrCl, PbO, PbS, which originate from the lead minerals. Lead in the form of the lead hydroxide gets its entry into the water from the lead pipes. Excessive intake of the lead by the humans causes disruption of the synthesis of the hemoglobin. It also results in the loss of appetite, anemia, kidney malfunctioning, nervous disorder and brain damage. Arsenic. The main source of arsenic compound in water are pesticide, fungicide and the herbicides. Arsenic contamination may also occur due to the discharge of some other industrial waste. Dissolution of the arsenic mineral is another source of arsenic compounds. Arsenic third compound are highly toxic. The toxicity arises from the complexation of the arsenic third with the SH group of enzymes which lead to inhibition of the enzymatic action in human body. Since arsenic is structurally similar to the phosphorus, its presence interferes with the process of phosphoxylation in human body. Higher doses of the arsenic result in coagulation of proteins, which causes cramps, paralysis, and even death. Cadmium. Cadmium. Cadmium finds its way into the water from the industrial discharge and from the nickel cadmium batteries. It is highly toxic. Excessive dose causing kidney malfunctioning, anemia, disorder of bone marrow, etc. It may be mentioned that according to the International Register of Potentially Toxic Chemicals of United Nations Environment Programme, there are nearly 5 million non-chemicals in the world today and about 40,000 new chemicals are added to the list every year. Of these, about 75,000 chemicals are in common use, amongst which a large number are positively known to be toxic. A brief list of the toxic elements whose toxic ions are almost commonly present in the municipal and the industrial waters given in the table along with their sources and the adverse effect. Arsenic, pesticides, chemical waste, mining byproduct, adverse effect, enzyme inhibitor, carcinogenic. Beryllium, sources, nuclear power and the space industry coal, adverse effect, toxic, carcinogenic. As is well known, the normal growth and the development of animals and the human beings are brought about by specific enzyme present in their bodies. The toxic ion in general attack the active site of these enzymes, react with the SH group of the enzyme and thus cause their complete inactivation. As for example, the functioning of the metallo enzymes is inhibited by the replacement of the harmless metal ions of the enzyme by the toxic metal ions. It is to be noted pertinently that it is not the presence of a particular chemical but its concentration which actually matters in chemical toxicology. Thus, elements such as arsenic, aluminium, beryllium, cadmium, copper, cobalt, zinc, mercury, molybdenum, etc., which are listed as environmental hazards, act as nutrients in trace concentrations and are essential for normal growth and the development of animals and human beings. Arsenic trioxide, a deadly poison, is known to act as a tonic at trace concentrations. This means that for the pollution control, we have only to control the concentration of the toxic elements. Any number of toxic elements may be present in drinking water, but as long as their concentration are below the prescribed limits, they are harmless. The permissible limits for some common elements, as laid down by the United States Public Health Drinking Water Standards given in the Table 3rd. The Bureau of Indian Standards values wherever available are also included in the table. The drinking water should be colorless and the odorless. Its pH should lie between 6 and the 9. It should be free from harmful microorganisms and its dissolved oxygen content should lie between the 4 and the 6 ppm. It should not contain the above mentioned chemicals beyond their permissible limits of concentration. 6. Sediments. Sediments are particles of soil and minerals which are washed from the croplands, undeveloped lands, unprotected forests, soils, overgrazed pastures, strip mines, road, bulldozed urban area by storms and the flood waters. Sediment fill reservoirs, stream channels, plug water filters, erode power turbines and pumping equipment and reduce the amount of the sunlight available to the green aquatic plants. The sediment also cover the fish nest, the egg laid by them in water and their food supplies. This reduces the population of the fish and the shellfish. 7th, radioactive substances. Radioactive substances from the nuclear power plants, waste of the uranium and the thorium mining and the refining, and from industries and the institutions which utilize radioactive material, if carried by water, become source of harmful radiations. 8th, heat. Large amount of water are used for cooling purposes in thermal and the nuclear power plants. Water is also used as a coolant in some industries. Cooling water is thus discharged at a raised temperature. The increased temperature have several adverse effects on certain properties of water. The rates at which chemical reaction occur increase considerably. This results in faster assimilation of the water waste and hence faster depletion of the dissolved oxygen, which affects aquatic life. The rate of evaporation also increases appreciably with increase in temperature. This results in greater wastage of water in the form of its vapor and so on. 9. Oil. Oil pollution results from the discharge of the oil from the oil tankers and the offshore drilling rigs accidentally or intentionally. An example of accidental oil discharge was the release of the about metric tons of Kuwaiti oil on March 18, 1967, when the ship ran aground off Cornwall near England and broke into three pieces. The Royal Air Force spent several days trying to set the oil afire with high explosive. Even now, several large tanker accidents are occurring every year. The most serious environmental hazard in the living history was caused by the spilling and the burning of tremendous quantity of oil emanating from the Kuwaiti oil wells, which were blasted off in the Gulf War by the Iraqi troops when they were forced to retreat. The awfully hazardous pollution which was caused to the surrounding atmosphere and adjoining oceans was unprecedented. Enormous damage was done to the aquatic life. Oil is also discharged from the oil tankers intentionally. A tanker carrying a cargo of crude oil, after discharging the oil at the seaport, fills up its tank's seawater to act as a blast on the return trip. Before the tanker docks, the seawater ballast, contaminated with the small residues of oil left in the tank, is returned to the ocean. Some vessels which use oil fuel also tend to produce oil slicks when wastewater or seawater blast is dumped into the ocean from the fuel tanks. The most adverse effect of the oil pollution is on the seabirds. The oil penetrates their feather, displacing the air which is normally trapped in the feathers and provides buoyancy and the insulation against the cold. The elimination of the entrapped air makes the bird colder and more susceptible to disease. In the absence of the entrapped air, the birds experience difficulty in flying. For instance, about 10 lakh birds lost their lives when Kuwaiti oil tanker met with an accident on March 18, 1967. Oil pollution adversely affects the other ocean life as well. Some of the constituents of oil, such as the 3,4-benchpyrene, are carcinogenic. 10th, detergents. Detergents comprise of surfactants. Detergent comprise of surfactant, that is surface active agents, which are organic compounds having polar or hydrophilic groups such as the carboxylic group NH4 positive or non-polar group soluble in water. Some common detergents are given below. LAS linear alkyl sulfonates, alkyl benzene sulfonates, quaternary ammonium sulfates are the surfactants in detergents cause a variety of the pollution problem, some of which are as follows. First one, the surfactants are highly resistant to the action of biological agents and thus don't undergo biodegradation. Since the surfactants tend to retain their identity, their elimination from the municipal waste water by the usual treatment become problematic. Second one, surfactants tend to inhibit oxidation of organic substances present in wastewater by forming a sort of envelope around them, with the result that these substances don't undergo oxidative degradation during the treatment of wastewater. These substances, generally being toxic, cause severe water pollution to which there is no remedy. Third one, being surface active, the surfactants cover the surfaces of the small particles in colloidal suspension, thereby stabilizing them considerably. These colloidal particles thus don't aggregate and hence can't be easily filtered off during subsequent treatment. The stabilized colloidal particles also reduce the activity of biological filter beds and the activated sludge. Fourth one, the most undesirable effect of the surfactant is their tendency to produce stable foam in rivers, sometimes several meters high, especially at log gates. These foam extend over several hundred meters of the river water. The builders used in the preparation of the detergents mostly consist of sodium phosphate, which forms stable soluble complexes with hardness liberating ions such as the calcium 2 positive and the Mg2 positive. These complexes act as plant nutrients and support rich growth of the aquatic plants, which deplete dissolved oxygen when alive and produce disagreeable smell on decay. In the view of the above problems, Research is now going on to discover surfactants which are biodegradable and which are the non-phosphatic. In the view of the above problems, research is now going on to discover surfactants which are the biodegradable and builders which are the non-phosphatic.